Hello everyone and welcome to Basic Probability Rules. So in today's meeting we are going to discuss the basic probability rules that form the foundation for everything we use or we will use in this class so far. All right, so the first rule is probability of any event A is between 0 and 1. So the probability is always between 0 and 1. 0 means probability of the sample space, probability of the empty set is 0 and probability of the sample space is 1. Number 4, if we have two mutually exclusive or disjoint events, which means suppose this is our sample space and this is A, this is B. So A and B are mutually exclusive or disjoint events, means no overlap, no common elements in both A and B. If this is the case, then probability A union B equals just the sum of the two probabilities, which means probability of A plus probability of B. So let me give you an example of this scenario. So, for example, when you flip a coin, you may get head or tail, right? So what is the probability of tail union head? Okay, so probability of tail union, or we can say tail or head. Now, the two events are disjoint or mutually exclusive because there is no way to get overlap or elements in both of them. So you get tail or head, right? There is no common elements in both of them. Okay, because they are disjoint or mutually exclusive, this means probability of T or tail plus probability of head. And probability of getting a tail is 1/2. Probability of getting head is 1/2. So the answer is 1. All right, so this is when we have a disjoint or mutually exclusive events. Now, some of you may ask, how about if we have like overlap? The next is the complement rule. The complement rule says probability of A complement equals 1 minus probability of A. Okay, why? Because if we have A, and this is the complement of A, and this is the entire sample space. So the event A and the complement of that event, they form the entire sample space, right? Because by notation, A union A complement equals the entire sample space, right? And A complement are disjoint events. So this means probability of A union A complement equals probability of A plus probability of A complement. Because again, A and A complement are disjoint events, by using the previous formula, then probability of the union or the OR of those two events equals the sum of the probabilities. So this probability, which is this, equals probability of the sample space, right, which is 1. So probability of A plus probability of A complement equals 1. Therefore, probability of A complement plus probability of A complement equals 1. Therefore, probability of A complement equals 1 minus probability of A. Okay, so this is the complement rule. It's a very basic formula, but it's very powerful formula in probability. All right, next we are going to discuss the additive rule. In general, if we have any two events, A and B, then probability A union B equals probability of A plus probability of B minus probability of the intersection. Why do we subtract probability of the intersection? So the answer is here. So if we look at this diagram, this is the sample space. Suppose we have A and B. Okay, so we have overlap. So this is A, and we have B. Now, if we just add probability of A plus probability of B, in this case, we double count the overlap. So this part is the intersection or the overlap between A and B. So as you see, we count this twice. All right? So this is why we have to subtract probability A intersection B. So probability A union B equals probability of A plus probability of B minus probability of the intersection. So in this case, when we subtract the intersection, probability of the intersection, in this case, we count the overlap one time, not double count the overlap. All right? In this example, suppose probability of A equals 25%, probability of B is 40%, probability of A union B equals 55%. Find part 1, probability of A complement. All right, so we know the complement rule, right? So the complement rule says probability of A plus probability of A complement equals 1, or you can say probability of A complement equals 1 minus probability of A, right? And probability of A is given, which is 0.25. So 1 minus 0.25 equals 0.75. So probability of A complement equals 1 minus probability of A, or 75%. What is probability of A intersection B? All right, so which formula should we use? If you look at the question, we have probability of A, we have probability of B, we have probability of A union B, right? So probability of A union B equals probability of A plus probability of B minus probability of A intersection B, right? Now, probability of A is given, probability of B is given, and probability of A union B is given. So we can solve for probability of A intersection B, right? So probability of A is 25%, probability of B is 40%. This is our target. And probability A union B is 55%. So 0.4 plus 0.25 is 65%. So we have to take away 0.10. So probability of A intersection B equals 0.10. All right? The last part, what is probability A complement intersection B complement? All right, so if you remember, when we discuss some basic operations like at union intersection, we discussed De Morgan's law, and De Morgan's law says probability of A complement intersection B complement equals probability of A union B everything complement, right? So this means probability A union B complement. All right, so today we discussed the complement rule, and we use it in part A. Probability of the complement of the event equals 1 minus probability of the event with no complement. So 1 minus probability A union B. And this probability is given, which is 0.55. So the answer is 0.45 or 45%. All right, so I hope this is clear, and thank you very much for watching.